Uh, Hello. So today we will start with the uh, today dynamic programming problems. So the first problem is unique paths. Okay. The problem says there is a robot on an M into N grid. Okay. The robot is initially located at the top left corner. Okay. The robot tries to move to the bottom right corner. This one. Okay. The robot can only move either down or right at any point in time. Okay, either robot can move down or right. Given two integers m and n, return the number of possible unique paths that robot can take to reach the bottom corner. The test cases are generated so that the answer will be less than or equal to this. Okay, so basically problem is saying that suppose this robot can start from here and it can go to either to the right or to the down, right, down, 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 right, means okay. And we need to reach here, so we need to find the unique number of paths this robot can basically follow to reach this position. Okay. So what we can do is we can use DFS, means we can try every path. Suppose we start from here and we go first to the most right position and then to the bottom position. Okay, so this is one path. uh, suppose we start suppose we are at this position, so from this particular position we can reach to finish position using these paths. This is first path, then this is second path, then this is third path. Means from this position to finish position we can reach to the from this position to finish position in basically three paths: this path and this path. So that's how we need to memorize it. Means from a particular position we can calculate that how many paths we can how many ways we can go to the other position, so that we don't have to recalculate for this particular position. So let's first write the recursive solution for it. So let's say we call a function find unique paths. Okay, and we pass the our initial position, which is 0 0, and the dimensions which are m and n. Basically these are the dimensions of this box. So I and j are our current cells, m is our length and n is our okay. So suppose if our I becomes m minus 1 and our j becomes n minus 1, so that means we have reached the end. Means we have reached the position finish position, and we can return 1 from here, that we have found a path. Okay, before that we also need to check if our I becomes m or greater than m, or our j becomes greater than equal to n. That means we haven't found any path, means we are going out of the boundary, so we can return 0 here itself. Now what we can do, we can move to two directions. First one is the let's say right direction. So how we can move to the right directions, means first we will find the path. We can number of paths we can go when we go to the right position. So int right paths will be, so in order to go to the right, we need to increment the column. Basically we are at 0 0 position, we will go to 0 1 position. So 0 1, so we have incremented 1, and m and n remains same. Similarly we can calculate the let's say down paths, means the total number of paths we can reach if we decide to go to the down position. So how we can move to down, we can increment the row number, and at the end we are supposed to return the total path. So basically what we can do, we can add these paths. So this will return us the total paths if we decide to go to the right and down. Okay, so we need to return this particular function. So let's run this. Okay, it's taking a lot of time. Okay, so here we have 28 paths, and for the second we have 3 paths. So we need to memorize it, because we are simply using the exponential solution. For every call we are calling two functions for the depth of let's say n. So basically this is 2 raised to the power n solution, which is exponential. So we need to memorize it. So as I have explained that suppose on to this block we can reach uh, from this path, from this path, uh, let's say from this path, from this path, from many paths we can reach to this particular block. And if we had already calculated the answer for this particular block to reach the finish position, so why we need to recalculate the path? We can return directly from here, so we can memorize it. So let's use the dp. So this will be our dp, will be equal to the parameters of the uh, grid, and we will initially fill this dp with the this dp matrix with the -1 values. So and then we can pass it in our function. And before going to the left or right calls, suppose for this particular box, we can check if we have already calculated answer for this particular box. So we can check if dp of I and j is not equal to -1, means we have already solved the answer for it. So we can return the dp of I and j. And if we haven't solved, then we will start from this box and calculate number of ways from this box to the finished position. So we will calculate it using these two functions, and after calculating we can store it in our dp so that in future we can use these values. Okay, so I think this is the way we memorize it. So let's see if this works. So let me add here the type also. Okay. Why it's taking too much time to compile? Don't know. We need to pass dp in these function calls also. Let's submit this. Okay, we have a pretty fast solution. So this is the solution we can implement. Okay, so let's fix the solution. So we can move to the next question. So the next question says longest common subsequence. Okay, so this problem is in, this is a basically classical dp problem. So the problem says we have two strings text1 and text2, return the length of their longest common subsequence. Okay, if there is no common subsequence, return 0. Okay, a subsequence of a string is a new string generated from the original string with some characters deleted without changing the relative order of the remaining characters. Okay, for example, ace is a subsequence of a b c d e. How ac is a subsequence of this particular string means we can delete some characters from this string and we can get this string. So we can suppose delete b and d from here, so we will be left only with the ace part. So that's how this is a subsequence of this string. So a common subsequence of those strings that is common to both strings. So here the answer is 3 because this is the longest subsequence in both, and here these are similar, so 3 is the answer. And here the no subsequence matches with, basically there is no common character, so that's why the answer is 0. So we need to find the I think length of the, okay, length of the longest common subsequence. Suppose we have this string ad fe and afd. So here the longest common subsequence will be ad. Why it's ad? Because suppose we delete this character from the below string f, then and delete two characters from this, we have this particular common substring with length 2. Basically we can't change the order of the strings, otherwise the answer will be different. So here we can't change the order to make ADF as the longest common subsequence. So the longest common subsequence will be AD, means we have to choose the order. So what we can do is we can keep a pointer on both strings, and whenever we see a matching character we can move our both the pointers ahead, meaning that we have found a match, then we are looking for the next character to match. So we need two pointers for the strings. So let's call a function find longest common subsequence. So we need a pointer on text A and text B, and we need texts, both texts. Okay, and this function will return us the longest common subsequence. So so this is the pointer to text 1, this is pointer to text 2, and this is our text 1. So let's call this as the, okay, let's call them text 1 and text 2. So base condition will be something like if our I pointer becomes greater than text 1's length, means if we have iterated all the characters of text 1, or if our j becomes greater than text 2's length, means if we have iterated whole text 2, then there's no point of matching, because we means one of the uh, string is exhausted, so we can't match anything, so we will return 0. Otherwise if we see if we can match the characters, means if text 1's character at ith position is equal to text 2's character at jth position, if these are equal, so we can say that we have found a match, means we can return or wait a second, okay, let's say if we have f, okay, if our characters match, then we can do is, means we have found a matching value. Okay, if we have found a matching value, then we can move both pointers ahead and uh, increment our both I and j pointers. This will not match to this. uh, Initially our pointers are 1, text 2. Initially our pointers are will be at 0 and 0 position, so this is not matching to this, but as we know here answer will be ADF, so this character will match with this character. So if our characters don't match, so what we can do is we can increment this particular uh, pointer, means we can increment I. And if our suppose strings are reverse, means if this was text2 and this was text1, then we need to increment the j. So means in this situation, first we try to increment I and check for the solution. Then we try to increment the j and look for a solution. Text1, text2. Okay, and out of these both two scenarios we need the maximum, means the maximum length we have found. Okay, so let's see if this works. Okay, so we need to memorize this. So what we can do is, for the particular position in the both string I and j, we can calculate that for these two particular positions we have calculated the number of the subsequences that match in the rest of the strings are this much. So that particular state we can store in the DP. So size of the DP will be text1 dot length and text2 dot length, and we need to initialize our DP with the -1 values. So we have filled the DP with -1 values, and now we can pass the DP in our function. And similarly in the previous question, like previous question, we can check if we have already calculated the answer for this particular state of the pointers. If not, then we can store the answer, and here also we need to store. Okay, we need to pass the DP here also. Okay, we need a 2D DP. Let's submit our problem. Okay, we have found submission. So I think it's till now we are solving the problems with the common template. So let's look at this particular problem. So I think these there are 4 to 5 problems on the best time to buy or a sell stock with different conditions. So this is one of them. So means these are famous problems, the stock related problems. So you can, I think, solve all the problems related to this. Okay, we have two more problems, and I think we have 4 to 5 problems in total. So let's read out this problem. So the problem says you are given an array prices where prices I is the price of the given stock on ith day. Okay, so basically in this array this is the price, basically this is the price of the stock on 0th day, this is on 2nd day, this is on 3rd day. Okay, so find the maximum profit you can achieve. You may complete as many as transactions you like. Okay, means transaction means buying and selling a stock multiple time. Okay, okay, means a transaction means buying a stock and selling a stock. That is a transaction, I think. And okay, but we have some restrictions. After you sell your stock, you cannot buy stock on the next day. Okay, means suppose we have bought a stock here on this particular day, and we have sold it as at a price of 2, meaning we have earned a 1 rupee profit. Okay, then we can't buy the stock on this day, means we have to skip this day, we can directly buy it on this day. Okay, so that means the cool down period means if we have sold it on this day, then we can't just uh, after selling this we on the very next day we can't buy it, means we have a 1 day cool down period. And we must sell a stock before buying a stock again, means we can't do like we buy a stock here and next day also we buy a stock, means before buying again we need to sell it first. Okay, so let's solve this. So let's say we define a function find max profit, and we start from the 0 day and we pass our prices array. Then let's define this function private int find max profit. So this is our day and this is our prices array. So if our base condition will be if our day becomes greater than this prices dot length, means we have all the days are passed, so we can't do anything, so we can't earn any profit, we can simply just return 0 here. Okay, so this was the base condition, and now we what we can do is we can have two options. Either we can buy a okay, okay. Means either we can buy a stock or we can sell a stock. So before that, we need to know that we have bought the stock already or we have sold the stock. Means ha- we need something to know that we are holding a stock. Means we already bought a stock and now we need to return it. Okay, so whatever we have means either we have holding a stock or either we need to buy a stock. But one thing for sure we can do is on a particular day is we can skip doing transaction on that day. Let's first define that. Skipping transaction means suppose we skip our transaction on this day. Let's call this I. Means we ask this is the ith day basically. So we can skip the transaction on the ith day. So like if skipping means let's call the function skip for skip. Skipping means we are simply moving to the I plus 1th index. Means we are moving to the next day. We are not doing any transaction. Means we are not buying any stock or selling any stock. Okay, now we have two options basically. uh, Either we can sell stock if we are holding a stock, else we can buy a stock if we are not holding a stock. So we need some condition, some boolean I think, that can define that we are holding a stock or we are not holding a stock. So let's say we use a array where we can store like zero value indicates that we are not holding a stock and means we need to buy. um, One means we are holding a stock and we just need to sell it. So let's say we define holding. Means we can pass zero initially that we are not holding a stock. So we can pass like holding a stock. Okay, so if holding is zero means we are not holding a stock initially, means we are passing zero, that means we are not holding any stock. So if holding is zero, that means we need to buy a stock, and to buy a stock we need to pay some money. Okay, so what we can do is we need to buy the stock. So what we can call is, let's use this skip variable. So we will take maximum of skipping and the buying call. So now we will be buying a stock. So buying a stock means we are paying for it, so we will lose some money from our profit. So we need to subtract the current price of I. Means basically we are buying, so we are paying this much money, so we are taking a negative value. Okay, so we will call this function wait a second, find max profit. and we will pass okay, so we are buying a stock, so we can just move to the next day, because we only have cooldown after we have sold the stock. So we can increment increment means we can go to the next day and pass our prices array. And now as we are holding a stock, so our holding value will become 1 means we are holding a stock now, because we have bought a stock and paid some money for it. So now we are holding a stock. Okay, and now we have else option means in this particular call we are holding a stock, we need to sell it. Okay, so if we are selling a stock means we are getting some money. So let's use this skip variable. So in this skip variable we will take maximum of skipping and selling the stock. So we are, if we are selling stock, we will add this value to our total profit. So means suppose we have bought a stock at 1 initially, then the next call comes here, and then we sell it at 2. So we have subtracted 1 means we are at -1, plus 2 means 1. So we have booked a profit of 1. So that's how this will work. So now we have some cool down period that we cannot do a transaction very next day, so we can do a transaction the next to next day. So we can add we can simply jump 2 days ahead, and then we can pass prices. And after we have sold the stock, now we are holding nothing, so we can set our holding variable to 0. And at the end we can return this skip variable. So we are keeping everything in our skip variable. Okay, so we can call this skip variable, wait a second, as the profit also, so that will not create any confusion. So basically this will be profit after skipping, this will be after buying, this will be after selling. Okay, so let's see if this works. It should work, I think, if we haven't done any mistakes, syntax error or something else. Why it's I think today my internet is not that good, that's why it's taking too long to calculate, to run the code. Okay, we need to add a semicolon here. I am faster than compiler, at least for from this lit code compiler. Okay, we need to pass here holding also. So we will pass the holding as it is, because we haven't done anything. So if we are holding, we keep holding. If we are not holding, we will not hold anything if we are skipping this. What error we are having? Okay, so our array's name is prices, not price. Okay, so now it's running. So similarly we need to memorize it also. So we memorize things, variables which are changing based on the variables changing. So here two variables are changing. First one is the day, and second one is the holding. So let's create a DP, and the size of the DP will be prices dot length means the number of days, and 2 because we are keeping two variables only, 0 and 1. So we will initialize our DP with the -1. So let's initialize our DP to -1. So arrays dot fill DP with array with -1. So we have initialized our dp with the -1. We can pass our dp in this function, and here also we can pass our dp. Okay, now we can check if we have for this particular state, means on ith day, if we have a holding value as this, we have already solved this sub problem or not. If it's not -1, that means we have already solved it. We can return the holding. Okay, else if we haven't solved, then we are calculating it here, so we can simply put our after all the calculation, our profit in this state, means in this state we can book this much profit. So that's the way to memorize it. We need to pass dp here also. Why I am always forgetting. And here also. Okay, let's submit this. Okay, we have a submission. So we have solved problem pretty fast today. So these are easy problems, that's why we are able to solve. Okay. mm, I think that is it for today. Thank you guys.